In this video, we're going to talk through the solutions to the final exam review number 5 for semester 2 of Algebra 1. And this is all multiple choice practice. So looking at this, which family function does the table model? Well, we have 4 different options here. So let's look up at the pattern in the table. So x is increasing at the same amount each time. When I look at this, I see that to go from 64 to 16, I'm decreasing by, well, if I can't figure out what that is right away, I could do 16 minus 64, that's minus 14. So I subtract 48, and then I subtract 12. So because I'm decreasing by a non-constant rate, I know it's not linear. I don't see, I also know it's actually not absolute value because it's not going at a constant rate. I don't see symmetry in the table, so I'm thinking it's not quadratic, but I'm not sure. So let's look and try and figure out what's going on. I know to go from 16 to 4, I divide by 4, and I divide by 4 to go from 4 to 1. So that tells me it's exponential. So I'm multiplying by 1/4 each time. So that is an exponential function. To write the equation, I remember that it's y equals a times b to the x, where a is the y-intercept. So to work backwards, I can do that. Multiply by 4, I get 256. So my a value is 256. My b value is a common ratio, which is 1/4 raised to the x. For this graph, there's a couple of different ways I can look at this. I have these possibilities for my 4 equations. So I know it's y equals a times b to the x. All of these are in exponential form. We have an exponential curve. The a value, if I remember from what we were just talking about, is my y-intercept. So I either have a y-intercept of 3, -3, or -5. Well, when you look at this y-intercept is -3. So that tells me right away a must be 3. These other options don't work. If this weren't multiple choice, I could go through the process of making a table. Because I know it's an exponential curve, I know it has to be an exponential function, which means that as x increases at a constant rate, we have a common ratio. So I am multiplying here by 5. So I could write the equation that way. Y-intercept of -3, common ratio of 5. For here, the domain will be all real numbers because this graph goes forever going to the left and the right. The range, though, when we look at this, the graph is approaching the x-axis but does not cross it, which means it's going to be y is either greater than or less than 0. Because it's below 0, we know all the y values are less than 0. Make sure it's not equal to because it does not actually reach the x-axis. Scooching down here, which of the following functions would have a graph with a vertical shrink? Well, vertical shrink I know really means wider than the parent function, and that's going to happen when a is between 0 and 1. So when I look at this, a here is 0.75. That'll be a vertical shrink. Here, 9/5 is a fraction, so sometimes we think it's going to be less than 1, but 9/5 is greater than 1, so 2 will not work. 3, we have a negative value, so sometimes we think shrink because it's negative, but that negative reflects it. It's really the 5 that affects the vertical stretch or shrink, and because 5 is greater than 1, that will be a vertical stretch, or will make it narrower than the parent function. This a value is 3/7, and that's less than 1, so that'll be a vertical shrink. And this guy over here, the a value is 1.5, so that will be a vertical stretch. That's greater than 1. So our answers are 1 and 4 only. That would be answer B. Scooching down here, find the vertex of the function. I know the vertex from a table is where we're symmetrical about, so I see a 1 and a 1, a 4, a 4. This guy right here is in the middle. I also know the vertex is where the graph changes from increasing to decreasing, and that happens at this point as well. So there's our vertex. Our y-intercept is where where x is 0, so I know it's going to be 0 comma something, and I see that right here in the table. That's our y-intercept. So 0 comma 4. The minimum or maximum value occurs at the vertex. So because we go from increasing to decreasing, the graph will be opening down. That means this will be the highest point, or the maximum, and that happens where, so the highest y value would be 5 then. And the equation, I notice that this is quadratic because we are symmetrical, but we are not increasing or decreasing at a constant rate. So I look at this, I see we are subtracting 2 each time. So our a value is going to be the second difference divided by 2, or -1. To write a quadratic equation, I can write it in 3 different forms: standard form, intercept form, or vertex form. Because I've identified the vertex right away, I'm going to go ahead and write this in vertex form. Y equals, our a is -1, x minus h, we're really going to see a +1 here because h is a -1, and then plus k, we'll have +5. Switching down here to examples 5 through 7, it says we need to use these 3 functions. They all model the same function, and we'll use them to answer the following questions. So this one says, identify the axis of symmetry of f of x. Well, we can find axis of symmetry a lot of different ways. When it was in vertex form, we knew that the axis of symmetry went right through the vertex. So we could get the equation right away. So when I look at these, this guy right here is in vertex form. I know that the vertex is going to be a positive 2, 25, which means in my graph, the axis of symmetry, this is opening up, so we have a parabola opening up. This is going to be at 2, 25. The axis of symmetry goes right down the middle. That's at x equals 2. The answer is A. But I could have done this in any form. I could look at standard form, for example, and I remember that standard form, my axis of symmetry, would be x equals the opposite of b divided by 2a. So in this case, negative 4 divided by 2 times negative 1, or negative 4 divided by negative 2, which is still 2. Or in intercept form, I can identify the x-intercepts right away. My x-intercepts would be negative 3, 0, and 7, 0. So right in the middle of negative 3 and 7 would be a positive 2. To identify the y-intercept, I know that's when x equals 0. Again, I could take any one of these forms and substitute 0 in for x. The easiest one, in my opinion, would be substituted in for standard form. We get negative 0 squared plus 4 times 0 plus 21. And when we simplify that, we get 21. So 0, 21 is our y-intercept. And then finally, for the x-intercepts, I know that's when y equals 0. But when I look at this intercept form, I can identify them so quickly that we already identified them. Be very careful of your signs here. The other way, or the other tool that you have, is to go into y equals. You could enter in any one of these equations into y equals, and then go to the table, and we can identify a lot of this information from the table. So we can see here, we're symmetrical about this point right here, which tells me that's my vertex. So that would be my axis of symmetry. My y-intercept was an x is 0, so I see that right here. Oh, got a little pen there. And my x-intercept is when y is 0, so I can scroll until I find y is 0, and there's one x-intercept. And if I scroll up, I can see another x-intercept. So the graphing calculator is a very helpful tool here. If we flip to the back, number 8 says this equation represents the revenue meaning how much money is coming in, where P is the price. So depending on what I make my price of my product, I'm going to sell more or less product, which changes the amount of money I have coming in. It wants the maximum revenue, and as soon as I see the word maximum, vertex is brought to mind. I know the maximum is always occurring at the vertex. So I'm looking at this equation. Because it's in standard form, I know to find the vertex, I first have to find the axis of symmetry. And the axis of symmetry, when it's in standard form, is x equals, or in this case p equals, the opposite of b divided by 2 times a, or negative 300 divided by negative 30, which is a positive 10. Now, I see 10 here as an answer, so I might be prone to jump right to that, but this is p equals 10. That means the price is $10 when I have my maximum. But I want to know what is the maximum revenue, which means I'm trying to find R. So I need to finish finding my vertex. I know when the price is 10 is when I'm going to have my maximum revenue, so I'm going to substitute 10 in for P. There we go. And when I punch that in my calculator, I get that that's $13,500. So the revenue will be $13,500, and it happens when the price is 10. So the correct answer here would be B. Looking down at number 9, which of the following describes how this guy is transformed from its parent function? Well, this is going to be in vertex form, where A is 5, H is 0, and K is negative 3. When A is 5, that is a vertical stretch. It's not a vertical shrink. When H is 0 means we're not translating left or right at all. That's not going to happen. K is negative 3 means we are shifting it down or translating down. So we have 1 and 4, which would be the correct answer of D. Scooching down here for number 10, which one of the following is the domain and the range? So domain is all real numbers. When I look at this, all of these graphs go forever to the left and right, so all of the domains are all real numbers. So I need to look at the range to be more specific. Here, y is less than or equal to 2. Well, when I look at here, we have the lowest value of 2, but then we are above 2. So the range here would be y is greater than or equal to 2. Over here, we have our vertex is at 1, 2, which means 2 is the highest value, then we're below. So this is y is less than or equal to 2. So I'm thinking it's B. When I move over to C, this graph goes forever up and down and left and right. So the domain and range here are both all real numbers, so it would not be C. So the correct answer is B. Here's asking us to write the domain and range for all the incorrect answers, so that is the correct answer. I don't need to worry about it. Over here, the domain we talked about, because the graph goes forever to the left and right, the domain would be all real numbers. Scooching down here for number 11, says says which of the following is a factor of this expression? So we need to factor the expression in order to figure out which one of these will be a factor. The first step in factoring is to factor out the greatest common factor, and the greatest common factor of these three terms is 1, so I can move on to continue factoring. We factor by grouping here, so we need two things that multiply to be a times c, or negative 12, and add to be 1. I know those numbers are 4 and negative 3, and then I have to look, because a is not 1, I have to use factor by grouping. I cannot jump right from here to my factors. So I have 6x squared and a negative 2, 4x and a negative 3. The GCF of these two terms is 3x. 3x times 2x is 6x squared. 3x times a negative 1 is negative 3x. The GCF, or greatest common factor, of these two terms is 2, and I double check this. 2 times 2x is 4x. 2 times negative 1 is a negative 2. So in factored form, I get 2x minus 1 times 3x plus 2. So when I look at these, I got to be very careful of the signs. B is the correct answer here. But don't be tricked by these other ones that are very close. Finally, actually not finally, second to last, number 12, I'm solving this square root equation. I know to solve square root equations I have to do the inverse, which is squaring. So I'm left with x plus 6 equals x squared. Now I see an x squared and an x, which tells me this is a quadratic equation that can be written in standard form, which means I need 0 on one side. So we could subtract x squared, but if I do that I'm going to have a negative x squared, and I like to keep the leading coefficient positive 1. So I'm going to subtract x and subtract 6, and when I do that I get 0 equals x squared minus x minus 6. And now I can try and factor. The greatest common factor is 1, so I can move on to my product sum. I need two things that multiply to be negative 6 and add to be negative 1. That would be negative 3 and a positive 2. Because a is 1, or the leading coefficient is 1, I can do x minus 3 times x plus 2 equals 0 and finish solving. I finish solving using the zero product property. We get x equals 3 and x equals negative 2. But I remember with square root equations, I got to check my answer because I have to check for extraneous solutions. Remember when we graphed the square roots, we had the bottom part or the top part of that parabola that could create extraneous solutions, so I have to check. So the square root of 3 plus 6, I want to know, does that equal 3? Well, that's the square root of 9, and 3 does equal 3, so that one works. So I know that A would not work, because I know x equals 3 has to be a solution, so maybe it's B. I know C won't work because I know x equals 3 is a solution, but it could also be D, so now I got to check x equals negative 2. So the square root of negative 2 plus 6, does that equal negative 2? Well, that's the square root of 4, and 2 does not equal negative 2, so D will not work. My only solution is x equals 3. And finally, number 13, what is the transformation of this function from its parent function? Well, I see that the a is 2/3. That's going to be a vertical shrink. The h is 2. That will translate right 2. And the k is 3, which means we're going to translate up 3. So is it a vertical stretch? No, it was a vertical shrink. Was it translated up 3? Yeah, I'm pretty sure that's the right answer. Let's check the rest of them. Translate left 2? No, we went right 2. And reflection? No, we were only going to have a reflection if you saw a negative out front, and we don't. So there is our final answer.